I'm very proud of all what Elizabeth have done. And we are here now to hear a summary of the years that she has invested in this research. Thank you very much, Elizabeth. Without saying more, so please go ahead and start.
Okay. Thank you, Dr. Feria, for that introduction. And she's so right. It's been nearly 3 years that I have been following this plant along. And so let me go ahead and read the title to you. Our title for today's presentation is Understanding the Distribution and Abundance of Asclepias Prostrata in South Texas. So Asclepias prostrata is a type of milkweed, and it was just most recently listed as federally endangered. And we'll go ahead and talk about some of the reasons why that's happening. So before we get into all of the information that I have, which was actually very difficult, so trying to condense 3 years of work in 30 minutes, I'm going to try my best, and hopefully I can get you all out of here within 30 minutes. So I'll give you a background. I'll talk about some of the soil mapping that I did, observations out in the field, some observations of insects as far as pollination goes, extraction and transplanting of the plant, and then lastly, seed viability, along with some concluding remarks. So as far as the plant is concerned, it was described in the 60s by Mr. Blackwell. We know that it's a perennial species and it loves to be exposed to full sunlight. And if you look at the plant here, you notice that it doesn't really grow more than, I would say no more than 2 to 3 inches up high. So really it grows what we call prostrate, just that it kind of grows along the ground. And so although it is really cool to look at, this is one of probably its biggest downfalls, in that if anything that is a little bit taller than this plant grows near it or on top of it, it's going to compete for sun exposure and eventually could get outcompeted. So given that it is endemic and it has a rating of G1S1, meaning that globally it's almost on the verge of extinction. And then S1 also is that it's of high importance in the state. As far as the Texas populations, it's currently found in Starr County and Zapata County. There are some locations in Mexico, but for my work was only done in South Texas. Between those 2 counties, we primarily have found it in Starr County, and I'll give a little bit more information about that in a second. As far as the justification, aside from it being an endangered plant species, it was highlighted in the status of the species status assessment that it's one of the most poorly known species of milkweed. So given that, we went forward and did this research. Man, I'm so nervous right now. I'm sorry. But also to reiterate, I did start this before it was even proposed or listed as endangered. And one of the reasons why is because my family lives in Starr County in Roma. And so knowing that, it really kind of piqued my interest, and I really wanted to pursue research on this plant. So some of the pressures that this plant is undergoing is, it's kind of like everything now that you see everywhere as far as habitat loss. So urbanization, meaning that it's being lost or converted into maybe a residential structure or roads. And then once we make the roads, we have to maintain those roads. Additionally, we see a lot of cattle grazing or rangeland expansion, which is okay. But what happens is that when we bring in invasive species like the buffalo grass, those will outcompete habitat for this plant. And then also, we did have a lot of oil and gas in Starr and Zapata County, but now we're also seeing a lot of wind turbines go up. And then lastly, one of kind of like the new pressures is the border wall, the federal border wall, as well as the state border wall that we'll get into in a second. So one of the first things that I did was I tried to look for the plant as much as I could. So in 2021, I had found a few plants, maybe like 20 different plants. And so I wanted to see if there was any correlations with the soil, like where we actually find the plant and if we could find the same exact soil in protected lands. So in Starr County, there's quite a number of protected lands that are government owned by U.S. Fish and Wildlife. And so I wanted to see if we could find those same soils. And so with that, I plugged that into Web Soil Survey, which is a free website, and it'll show you the types of soil and the percentages. And AOI just stands for area of interest. So I kind of took that as like a preliminary result, and then I did some mapping. And so on GIS, I checked to see if we could find some correlating sands or sandy soils, and we did. So we found 3 different types of soils. So we found the Copita fine sandy loam, the Carrerita clay, and then the Jimenez Quemado. So these that you see in pink are actually the U.S. Fish and Wildlife tracts. And then the different colors, the green, the orange, the blue, those are the soils that you could potentially find on there. And so given that those soils are there, we could probably maybe deem these as suitable habitat if we wanted to restore the milkweed populations on these properties. So I had done this work back in 2021, and since then they have put some federal border wall through. I'm not sure if it was 2 of these tracks. It might have been more, but I know that they have plans to build within more of these protected lands. So some other field observations that I was able to see throughout the years is in the species status assessment, it was noted that they saw a lot of growth between the months of March through October, which is completely true. From what I saw, mostly in the summer, like July and August is when you really, really see this plant out and blooming. It's kind of crazy that this plant is super, super green and then everything else is kind of like dying in the back. But for some reason, this plant, it just loves it. It loves 100-degree temperatures, little rainfall. But I actually was able to see that this plant was flowering in the month of December, which is something that hadn't been noted before. So we could just assume that if there is adequate amount of rainfall and just proper environmental factors, that you could see this plant out and also blooming. Additionally, I was able to see a lot of variation as far as what it looks like. So mostly you see it and it's like a beautiful green color, but sometimes I might have seen this maybe 5 or 6 times that this plant almost looked like completely black. So that was just something I wanted to note, which is kind of cool. I'm not sure if it's a form of sun stress or not, but it is kind of like a purple or a blackened color. And then additionally on the right-hand side, when the plant is in an area that is exposed or not exposed to a lot of sunlight, it starts to try to elongate itself, which is called the shade avoidance syndrome, which is something I learned in Dr. Christopherson's class. I think he is in here. So if you're hearing this, or this is because of your class. And so you'll notice that the leaves, they're not as jagged. They have more, like they're trying to have more surface area to be able to be exposed to the sunlight, and then those elongated stems. So given that we have a lot more invasive grass species coming, we might see more plants expressing this shade avoidance syndrome. Additionally, so now we're moving into the pollinator section. So this plant is known as an obligate outcrosser, meaning that it does need to get pollen from a separate plant to be able to produce a fruit pod. And so from the species status assessment from the government document, they noted that there wasn't any known pollinators. Since then, we do know of a few, and just to recall, this is from 2020, but this is what I was working with at the time. And so not all visitors that go to this plant can be considered an effective pollinator. This plant, the flower, has a really, really unique anatomy. It has what's called like a trapdoor system, where an insect has to have a long enough limb to be able to somehow slip into that flower and then be strong enough to be able to pull out what we call the pollinia, which has pollen attached to it, and then take it to another flower. And so we had kind of assumed that it had to be a large type of insect, some sort of bee or wasp, to be able to do that process of pollinating. So again, not any insect that actually visits, like a butterfly. They're not technically a pollinator if they're not really getting that pollinia out. And so it was known that in another species, which is the Zizotes milkweed, that tarantula hawks were actually an effective pollinator. And so I did actually see that, but I didn't get the chance to see if it had pollinia attached to its limbs. And so it wasn't until a few months later that I saw a different type of wasp. It's a little bit smaller than a tarantula hawk wasp, and this is a different type of spider wasp, but it's still very closely related to the tarantula hawk. And so this one is called Notocyphus dorsalis. It doesn't have a common name yet. It actually doesn't even have like a Wikipedia page, but you'll see it has like this beautiful orange on the back of its head and its neck. Really, really cool animal. And so how I was able to determine that it was an effective pollinator was that I had to actually like capture it. So there she is in a jar. And trust me, I felt really guilty about this. So I captured her and I put her under the microscope. And then there you could see on her limb, you do have a piece of pollinia that it is attached. So this one we could mark as an effective pollinator. And so given that these wasps are like they're large, we can kind of assume that they have a really big like foraging range. So even though we might have a population of Prostrata here, maybe they can take that pollinia a few kilometers away and kind of send those genetics elsewhere, which is actually, probably like hopeful in my opinion. And then lastly, as far as insect interactions, is the monarch butterfly. So in the species assessment, they really didn't note the monarch butterfly, but it was kind of understood that we know that the monarch does use milkweed as a host plant, but it really hadn't been documented. And so I was lucky enough to get a picture of a monarch butterfly. And then on the right, we have some monarch caterpillars. So now we can actually like say like, yes, monarch butterfly does use this species of milkweed to actually lay eggs and then also feed on. So moving on to the extraction part. So this part of my thesis journey wasn't really planned. It was kind of just out of the blue, but still really, really cool experience. And so let's go ahead and talk about it. So in spring break, which was this year, there was a ranch that was going to have state border wall put through it. And so we knew that that property had a lot of really rare species of plants, including the plant that I study. And so I got an email and a call if I could go and survey the property for this plant, because as you kind of seen in other photos, it can be really tricky to identify. If it's not in bloom, it's really hard to identify. So we kind of had this task of trying to find these plants within a certain threshold where that wall was going to be built. And I'll show you again what that looks like in a second. But so some of the questions that we had was, what does the plant look like underground? And since this land was going to be cleared, the objective was kind of like, well, the plants are going to die either way. So let's go ahead and look for them, excavate them, document the process, and maybe we could save them if we could transplant what we call the tuber part of the plant, which in this herbarium species, you can kind of see it to the right. Just under the stem, these kind of like bean-like structures, those are energy storing tubers. So what we knew at the time was that underground, they have a taproot that's about 1/4 of an inch in diameter, and that it could be up to 61 centimeters in length. It doesn't produce any rhizomes, but it does have those energy storing tubers. So we had a question as to how similar would be the findings that we find out in the field versus a herbarium species or a cultivated specimen. And so we hypothesized that taproots would be up to 12 inches beneath the soil surface. Additionally, that the tubers would be of similar size and morphology to cultivated species. And in this photo on the right, maybe you can see it, but there's a few of them here at the bottom. And I'm telling you, if you can easily miss these plants. And we found probably 2 to 3 groups, but only one of these groups was actually kind of in the pathway of where the wall was going to go. And you can kind of see the stake right there with the orange. That was like one of the stakes that shows that it's within the area of impact. So what we had to do is we had some consulting with the state botanist, and he kind of guided us as to how to carefully try and extract these plants as best as we could. And so he had told us to draw a perimeter around these plants and then kind of work inward very, very slowly. and to just be as careful as possible. So we had a large perimeter of about 18 inches wide, 12 inches deep, and then just kind of slowly worked our way inward. And so these were some of our findings. So what we saw was that in general, it was probably about 6 inches in length as far as from what you saw above ground to underground was about 6 inches. And then also that we did have some offshoots that were visible. So the photo on the right, you can see the tuber, you see one stem, and then you see it connected to another one. I did actually break that one. I wish I didn't, but you can kind of see it's like slightly broken. But either way, we were able to see some offshoots from there. And then also additionally that the taproots and the tubers varied in size, shape, as well as color. And as you can see from the photo, it was we were lucky that we had good weather, but it was very, very hard work actually to do that. So here's some close-up shots. And so you can kind of notice the thickness of some of these tubers. The one that I'm looking at is kind of like the carrot-shaped one. And you can kind of notice it's probably over or about half an inch thick. And then also the length you could also notice there. So what we actually did with these is that we took them and we put them in a pot to see if they would actually regrow. And if they did, hopefully they will produce seed for us that we could use for future restoration. And so we actually were lucky. So we did put them in a pot and we had two different results. So the one on the left, that one had some regrowth from just foliage and the stem. There was no tuber. And the one on the right, that's like really, really happy. That one actually did come from a tuber, and that tuber was buried about 5 inches below ground. So those were some really cool observations, results. Now we're moving on to the last part, which is seed viability. I was lucky enough to get to work with American Forests, and then I also had some help from Chris Bess and then some other people that I'll mention in a second. So some of the unknowns was how many seeds there are per like seed pod, and then also how long these seeds can live in a seed bank. So those were our givens. And so our questions were, is seed viability of prostrate milkweed similar to other closely related species, such as Zizotes milkweed and Emery's milkweed? And so I hypothesized that yes, it would be similar, given that they have a similar environment, like that they are both kind of exposed to so much sunlight, very little rainfall, and also that they overlap geographically. Wherever I have found prostrate milkweed, I have been able to find Zizotes milkweed. I've also been able to find Emery's milkweed. So I thought that those were two really good species to kind of use as comparison. And so how we actually catch these seeds is you can see on this picture here. This is kind of a common technique, and I don't know who actually came up with it. But so because these seeds are dispersed by the wind, you kind of have to put a jewelry bag mesh and then just kind of wait and hope that they stay all in that bag. It's kind of a waiting game. But so I was lucky enough to be able to catch seeds from 3 different populations, and then one was actually gifted from a friend. So as far as how long I've been collecting seeds, I started in June 2022 until recently, June 2023, so about a year. And so we were able to collect the Prostrata seeds, the Zizotes or the Ornithordes, and the Emery or Emery's milkweed. So all the seeds were counted, stored in ambient room temperature, and I took measurements and all of that good stuff. Hopefully that will be useful to someone in the future. And so one of the things with this was I was actually very terrified to do this because the plant is so rare. I was so scared that I would not be able to grow this plant or that I would waste the seeds. So we went ahead and chose to do a seed viability test through germination. And so I was given advice from Mr. James Lovegren of LNL Growers, and then also from Brad Grimm, which he runs a website called growmilkweedplants.com. So I kind of took stuff from both of them and then came up with a procedure for this. So I did like 3 rounds with 10 seeds each. And so what I did was I put the seeds inside of a paper towel. And so I did that so that the seeds could be completely submerged in the water. And I have a picture there on the top right. If you just put the seeds in the water they just like float to the top. Those seeds are very, very buoyant. They're very light. So when I put them in a paper towel, they kind of like all sank, and that really ensured that they were exposed to moisture all around. I also added 3 drops of dish soap. Uh, there's a few reasons for that, and James Lovegren had advised that it kind of acts as a surfactant, which means that it makes the water wetter, is actually what he said. So it's able to get inside of the seed much better. And then additionally, it could kind of act as an antibacterial if there is some sort of bacterial, or even an antifungal for fungal growth. So we did that. We put it on a heat mat, and it stayed at around 78 degrees Fahrenheit, give or take, and then took the seeds out. And then what we did was we actually clipped the seeds. So when you clip the seeds with just a general like toenail clipper, you expose the radicle, and it kind of like jump starts the germination. So if you do this, this can kind of bypass any dormancy if there is dormancy. And so let me show you what that looks like when those start to grow out. And this is at my house, like this, and it looks kind of like madness. It kind of stayed like that for a while too. So after I took the seeds out from soaking overnight, I put them in jars to aerate, which I just used an aquarium kind of bubbler that you could see there, and the seeds are just kind of spinning around. And so to me, I considered it to be germinated if that radicle elongated. So once that radicle elongates, I considered it like, yes, it germinated, and then I would transfer it to a soil mixture, and then eventually I would take it outside. And so I kind of had perfected this process to try and see if I could get like the most out of these seeds. And let me kind of show you the results. So out of all of the seeds that I was able to test, I had over 90% germination rate, which is very successful in my opinion. And I think I could still kind of tweak this process a little bit more. Like even some of them were 100%. So very, very successful. And it was very rewarding to know that given how rare this plant is, we can have a high success rate for germinating this plant. So 90% higher success rate for all of these Asclepias species, the Prostrata, the Zizotes, the Emeries. As far as like the oldest plant that I germinated for Prostrata, the oldest one was about 10 months old, but I still have seeds left over, so I could still kind of test that out and see like how old is maybe too old. So I still have leftover seeds that I could continue to test. So our oldest were 10 months old, and our youngest were about 6 months old. I do also want to note that my Zizotes and Emeries milkweed, the Ornithorhynchus and the Emery, if you notice the date that I collected and germinated, it was like right after, which really like shows how effective that clipping technique is. Like as soon as you harvest the seeds, you can clip them, germinate them, and have a very, very high success rate. Additionally, you don't need any cold stratification to complete this process. That's something that we see a lot in protocols for germinating milkweed, but because we live in such a hot climate, we found that you don't need any cold stratification to germinate the seeds. And so this is outside of the work, but I have the plants growing in my backyard. So I thought I'd take these photos and kind of show them. So I have the 3 different species here for you to look at. They're between 3 to 4 weeks old. And you can kind of see in the middle, the Prostrata, the endangered species, like how robust and how thick that taproot is compared to the other ones that are around the same age. Also, see if I can zoom in for you. Yes. Right here in the middle, if you can kind of see, there's a new stem that's forming from this tuber or taproot system right here, which is very cool. So some of the observations I've noticed is that they invest very, very quickly in their taproot system. And if you cut off the vegetation, the green part, they will regrow. Even being as young as they are, they will still come back. It's insane how resilient these plants are. So we're going into our concluding remarks as far as the future for this plant. So because there's a lot of pressures that are put on it, it's really like, well, what's going to happen? Our protected lands are being taken for one reason or another. People are converting their land for whatever, which they have every right to do. That's their private property, right? But given all of those things, what's the future for this plant? And so one of the suggestions that I have, you can kind of see like in this picture, and I'm wondering if anybody that doesn't know me can kind of see what I'm talking about. So in the front, you have the plant, but if you look in the background, we have these wind turbines. And so really what I'm suggesting or proposing is that maybe we could have some sort of cooperative with these energy development companies, right? So this is an awful photo, but this was the only one I could find. So this is my uncle and his ranch. He does have a wind turbine on his property. And if you're familiar with wind turbines, they have to clear the land around it, I guess, to make sure that the wind turbine is working effectively. So because they clear that land, maybe we could actually use this as habitat for our plant. It wouldn't be, outcompeted by tall plants or anything. It wouldn't be in the way of people that have to go monitor these wind turbines. It wouldn't be in the way of the property owners. So some sort of cooperative with energy development companies is something that I think would be really cool to look into. Additionally, we could still restore populations on the U.S. Fish and Wildlife tracts, maybe even the local state park, which is Falcon State Park, private ranches, and then, like I mentioned, our energy development properties. And so that's kind of concluding my presentation. And here you can kind of see the plants that I have in my backyard. And hopefully I can get them some homes soon. Let me go ahead and talk about my acknowledgements really quickly. So my committee members, thank you so much for your guidance and support. My biology and SEAMS department, I've learned so much from my professors. Like I'm so happy. Also, Dr. Durth, Dr. Durgle for helping me. Dr. Feria's lab, my boss, I think I saw that she's on here. So Dr. Cervantes, thank you for your continued support. Alan Williams for actually getting me into milkweed in general. And then Chris Best from US Fish and Wildlife for believing in me that I could actually do this. Dr. Fishbein also for just helping me, even though I'm not your student. I'm so happy that you were able to help me as much as you could. John Dale, Giselle Garza from American Forests. James Lovegren from L&L Growers, Rafael from Landhawk Consulting, and then John Brush. I'm not sure if you remember, but you did give me some Zizotes seeds, so very appreciative. And then you invited me for a talk at Quinta Mazatlan, so very happy. I did get some funding for my tuition, which is always nice. And so those scholarships are mentioned below, R&K Duggar Scholarship, and then Harry and KL Wheeler scholarships. These are my references. And then if you all have any questions, I'm open for questions.
Thank you very much, Elizabeth, for the excellent presentation. And I will serve as moderator. And I saw Julio Rodriguez. Were you raising your hand to talk?
Yes.
Thank you. Please go ahead.
Yeah. Hi, Elizabeth. In that page where you showed the areas where it was conducive for this plant to grow, how do you have a sense for how large those areas were?
Oh, I know the map.
The one that had the map. Yeah, the one that had the map.
No, I don't have a scale on there, which I'm glad that you mentioned it. I should put a scale. Some of them vary between 5 miles to maybe 10
so
miles.
They're pretty large. Mm-hmm. Okay. So that's good. Okay. Mm-hmm. And outside of those areas, it's just you didn't find any of these plants, huh?
So outside, I haven't actually surveyed inside of these properties, which I've been wanting to. Outside of them, though, that's all private property. I would need permission.
Oh, okay.
I would love to, yes. I'm always kind of looking for landowners that are willing to let me in and survey their property for these plants.
Mm-hmm. Okay, thank you.
Thank you very much. Anybody else? And if you have any comments, also questions that you want to write in the chat, I'll be happy also to read them and for Elizabeth to answer them. Yeah, John Brush says, happy I could be of help, and Brad Christopher Sonderland also brought something. Yeah, SAS, SAS. So questions, comments, we have time now for the audience. As it works, the logistics, once the audience had finished, and we thank all of you to be here today. We know it's Friday, summer is a busy time, and we appreciate your time here. I saw Chris Best, also John Dale, John Brush, that been participating with us in this project, attending. We appreciate your attendance today. So, Mark, John Dale says, great job, Elizabeth. Ruth Galan, great presentation, Elizabeth. Mark Fishner, great, congrats, Elizabeth, fantastic talk. Carlos Enriquez, excellent work, Liz. Sandra Espinosa, great job. And if you have questions, please let us know. Brad Christopherson, congrats, Elizabeth, very important work and learned a lot. Chris Best, TPD and USFWS are considering setting up an RFP for Section 6 funding to support continued work with the salvage milkweed seedlings. Hey, here's opportunity, Elizabeth. Thank you, Chris, for letting us know. Maria Cervantes, very proud of her excellent and committed work. Thank you very much, everybody. So, any questions, comments, feel free to ask. Elizabeth, now is time for her to just answer any other thing. I might have I have several questions, and I'm sure the committee members have, so we will wait until everybody is happy with any answers, any more comments, and we will let everybody go, and we will stay with Elizabeth to ask a little bit more questions. But hey, Elizabeth, just a general question for everybody. If you want to say something about the importance of plant conservation, what is your take-home message? It has been great for us, clear, but you want to say something else to people here about the importance of conserving native plants in the valley. So please go ahead, tell us a take-home message from all this work.
That's kind of a hard question. Let me try my best. So as far as, the importance of native plants, I mean, without these, you don't have what comes with it. You're not going to have the pollinators and who relies on those pollinators for food. So without having the base or the foundation, that really takes away the beauty. And as you may know, here in the Rio Grande Valley, we have a lot of migratory species, whether that be migratory butterflies, which like the monarch, they need this plant to be able to lay eggs, or we have migratory birds that need food or insects to eat while they are on their journey down south. So making sure that we do have all of those things are important for us. And we do know that there's a lot of people that travel down here to the Rio Grande Valley to see all of the beautiful birds right there in Roma in the Salinenyo area. That's a huge bird haven. So we know that it is very for one, it's profitable, but people really do find a lot of peace and joy from being outside and being amongst all of that beautiful, I guess we could say, nature, right? Plants, birds, insects, all of that. That's my take-home message.
Excellent take-home message, Elizabeth. We are very proud of all what you have done. And as Elizabeth mentioned, when she, can you hear me? When she started this work and the plan was still not listed, the contribution and the help, willingness of private landowners to help us to preserve biodiversity is critical. So if any of you here is a private landowner, thank you very much for helping us to preserve biodiversity in the valley. John Brush says, great work, clear presentation, and super cool you were able to figure out such efficient germination. Courtney Galley, great job. So since there is no more questions and everybody is very happy and pleased with your presentation, and I want to invite everybody here, please, Elizabeth, write your email here. So if anybody has any follow-up questions, comments, more ideas to keep supporting this kind of projects, please let us know, because as Elizabeth mentioned, the work doesn't stop here. As Elizabeth is a science teacher, inspiring, empowering other future scientists, we should keep working. We should keep bringing this to all levels of awareness about the importance of doing this, preserving biodiversity, and in this case, rare plants. Thank you very much, everybody. We will let you go now, and Dr. Carreon and Dr. Pereira